Hello, I'm Sergey Schindler with EMC, and I'm here to talk about the reference architecture program that we established at EMC to develop the integration with different OpenStack projects. Specifically, today I'll be talking about Cinder block storage. Over the next few minutes, I'll be talking about the reference architecture program, what's included, the scope of the program, as well as our OpenStack partners that are part of the program, our plans going forward. Some of the storage arrays that we've tested within the reference architecture version 1.0, the benefits for OpenStack admins and the storage admins, as well as the cloud operators, and the challenges and lessons learned. Today, pretty much every EMC array develops some sort of an integration with the Cinder project. Going forward, we plan to integrate the arrays that will be supporting the file systems and develop integration with Manila Project as well. Just to briefly provide an overview of the available Cinder drivers, today we offer the Cinder drivers for all-flash XtremIO that delivers extremely high-speed storage in all-flash configuration. Our workhorse is the VNX storage array that delivers lower cost per transaction for any Platform 2 or Platform 3 workload. Our software-defined storage called ScaleIO, which can be deployed on any additional drive of the OpenStack compute, now delivers high capacity for any kind of workload and high transaction speed with any white box or a commodity off-the-shelf hardware. And the workhorse of the EMC storage, the VMAX array that delivers the low-cost storage for a high-capacity applications, as well as a recently open-sourced product from EMC called Viper that delivers efficient storage management. So all of these products have Cinder capabilities either in the process of development or actually integrated in the trunk. Our reference architecture program delivers the certified and validated designs that were developed in partnership with customers and our partner distributors. We know customers have a choice of OpenStack distributions, so we reached out to our existing customers as well as new customers and talked to our OpenStack partners to develop the initial scope of the reference architecture. That includes 3 major distributions, specifically Canonical Ubuntu OpenStack distribution, Red Hat RHEL OSP distribution, as well as Mirantis OpenStack. The reference architecture program included the certification validation testing by both EMC and respective partners, and focusing on delivering integrated tool capabilities for future releases of our reference architecture program. Additionally, working with our partners and per our customer request, we developed a joint service and support program which will allow you, our customers, to simply place a single phone call to either EMC or our distribution partner to address any issues associated with OpenStack deployment using EMC storage. In this first release of the reference architecture, we've included 3 different types of EMC storage systems: VNX, the workhorse; XtremIO, the high-performance all-flash array; and a software-defined storage from ScaleIO. We've also included some of the fiber channel switches from our partners Brocade and Cisco, and focused on the functional testing only. This reference architecture program did not address any performance benchmarking or performance optimization. However, we provided extensive testing for XtremIO, VNX, and ScaleIO for both fiber channel and the iSCSI protocols, as well as covered the testing through the Horizon web interface, OpenStack CLIs, both Cinder and Nova CLI, as well as the API with our automated tests designed specifically for reference architecture program. Our focus was on delivering the best practice results, validating some of the best practices we learned from our professional services organizations, as well as talking to our customers, and uncovering any gotchas that would impede our customers' progress in deploying OpenStack using EMC storage. So as you can see in the diagram, we've deployed a distributed OpenStack cluster in high availability configuration with a minimum of 3 OpenStack controllers and a minimum of 7 OpenStack compute nodes that were integrated with EMC, VNX, XtremIO, and ScaleIO arrays. In case of ScaleIO, the additional drives on each of the compute nodes were aggregated into a single storage pool and exposed by ScaleIO through the REST API using the ScaleIO gateway. For VNX and XtremIO, we've tested both fiber channel and iSCSI configurations using both Brocade fiber channel switch with auto zoning support, as well as a Cisco MDS fiber channel switch with manual zoning support. An architectural deep dive into our configuration included the deployment of Cinder drivers for respective arrays. For example, the VNX Cinder driver is actually included with the June release and will continue to be available in the trunk going from June onward. So it is available in Kilo, will be available in Liberty as well. We will keep adding the capabilities to the drivers to support both extending array capabilities as well as a new Cinder functionality. VNX driver deployment includes a deployment of the Navi CLI. That's our command line interface that Cinder driver is using to access the VNX array. The XtremIO array itself is accessed through the RESTful API, which is called by the XtremIO Cinder driver. And in case of the ScaleIO, once the ScaleIO SDSs and SDCs were deployed on the compute nodes, the REST API was deployed on one of the OpenStack controllers and was accessed by the driver using the REST API. So to provide you with a very quick overview of the storage systems that we included in the reference architecture, the workhorse of the EMC storage is the VNX, which provides both unified block and file storage support. In this first version of the reference architecture, we only validated the block storage capabilities using both fiber channel and iSCSI support. VNX supports the majority of the volume operations, from creating the volume, deleting the volume, extending the volume, as well as the multiple volume types that are supported by the backend VNX storage. Types, for example, like a deduplicated volume or compressed volume, thick or thin volume, etc. And as a part of our testing and validation activities, we performed all this functional operations and volume lifecycle management. The XtremIO array is, as I mentioned, all-flash array designed specifically for high-performance applications. It is easily scaled out by adding additional XtremIO bricks, supports both fiber channel and iSCSI protocols, and as I also mentioned, integrated into the OpenStack trunk starting with the June release. XtremIO support main volume lifecycle operations, such as creating the volume, extending the volume, deleting the volume, creating snapshots and backups. With the ScaleIO block services, the ScaleIO was deployed on ScaleIO SDCs and SDSs were deployed on all the compute nodes, as well as the ScaleIO gateway and MDMs were deployed on the controller nodes. ScaleIO driver reached the REST API gateway through the REST calls and has been supported since the Havana release. ScaleIO is being distributed as we call it as a freemium. So the free, unlimited, unrestricted download will become available at the end of May, specifically on the May 29th this year. This table summarizes the volume operations that we've tested for each of these 3 arrays. As you can see, the majority of the volume capabilities are supported for VNX, as well as VMAX and the Viper, which will be part of our next release of the reference architecture program. And different volume operations and lifecycle management capabilities were tested for both XtremIO and ScaleIO. So this metrics is available on openstack.org under Cinder support metrics, and all these capabilities are listed there. At the same time, the drivers themselves As I mentioned, for VNX and XtremIO are part of the trunk. Driver for ScaleIO is available from EMC support, but will also be available on the GitHub soon. We've tested, in addition to individual array configurations, we've turned it MultiBackend Support, which is useful in a multi-tiering applications where the development, for example, can be done on a low-cost distributed software-defined storage such as ScaleIO, and the production deployment could be then moved using the additional backend directly to the VNX or in the future to the vMux for higher tiered, higher grade storage requirements. Some of the lessons we've learned during the course of this reference architecture program were specific to the distributions. In many of our vendors in the partner distributions, some of the utilities that are required for multipathing support, for iSCSI support, are simply not part of the distribution and required to be downloaded from either GitHub or from the partner websites. Additionally, some of the out-of-the-box default configuration settings needed to be changed for proper operations of the array or the Cinder driver. Things like missing Python libraries, all that has been identified and included in our reference architecture documentation. This reference architecture included, as I mentioned earlier, three partners initially, and as you can see, I'm wearing the lanyards for all three partners, which took me a little bit to collect here at OpenStack Summit in Vancouver. We've released Mirantis reference architecture 2 weeks ago on May 7th, and we just announced the availability of the canonical reference architecture that has been available yesterday. Red Hat reference architecture is in the works and should be available early in the next quarter. One other thing we learned during this reference architecture is the dangers of messing around with the partner high availability configurations. For each of the validated partners, their high availability is implemented through different mechanisms, and you as a customer using this reference architecture has to be very careful in applying the configuration changes to make sure that you're aware of the specific high availability mechanism deployed by your distribution vendor. What are we planning to do in the version 2.0? First of all, of course, it'll support Kilo, and additional Cinder capabilities introduced in the Kilo release. We also plan to add EMC arrays, other storage systems such as the vMux and EMC Viper, which has been open sourced under the name of Copperhead and is freely available for download. Additionally, we're going to work with our partners to develop integration with their deployment tools, things like Mirantis Fuel, Canonical, Juju Charms, which have been made available with our recent release of the reference architecture, as well as the Red Hat Foreman. We also consider including additional projects associated with the storage capabilities, such as Manila Project. As you know, with the incubation of Manila, our team's already working on the development of the drivers for Manila, specifically teams from Isilon, as well as the VNX divisions of EMC. With Manila Project, we plan to introduce support for VNX drivers, Isilon drivers, as well as a Viper driver that will support a shared file system under Manila. To summarize, with this Kilo release, EMC drivers for Cinder are available for vMux, VNX, XtremIO, and ScaleIO. And with incubation of Manila, Isilon, and VNX will provide support for Manila drivers relatively soon. Some of the takeaways from our reference architecture program include a demonstration of the strong commitment to OpenStack community by all members of the EMC Federation, EMC itself, Pivotal, and VMware. I hope you gained a good understanding of the integration flow for Cinder with EMC storage arrays and the specific challenges associated with various storage protocols that we tested, and benefits of using heterogeneous storage for different type of workloads in the P2 or P3 platform. These reference architectures that are now available on both EMC website using the links below, as well as a partner website. They've been announced on both Mirantis OpenStack website with a very interesting write-up as well as the canonical website. And I welcome you to attend other EMC breakout sessions here at the summit at your convenience. Thank you very much.